Learning outcome 5. So we define the activity of a source. And remember I mentioned yesterday, the words activity and radioactivity have different meanings. They don't mean the same thing. You can't interchange them. So radioactivity is a name of a topic that we're studying. Activity is what we're about to define here. It's got a precise meaning, right? So you can't just kind of change those words. And it's quite a simple definition. For basically trying to think about how much radiation something gives out, then it's the number of atoms which decay in 1 second. So decay means to give out radiation, to change from being unstable to being stable. So learning outcome 6 is that formula A equals N over T. So A stands for activity, and it's measured in becquerels, so we're introducing a new unit, and that's abbreviated as BQ. Okay, so it's a French name, becquerels, but BQ, where 1 becquerel means 1 atom decays every second. Now that's actually a very low activity, and often we'll come across kilobecquerels or megabecquerels. Remember those prefixes that we introduced? So kilo is 10 to the 3, mega 10 to the 6. N is the number of atoms which decay. And T is the time, but it's got to be measured in seconds because we've defined activity as a number of atoms which decay in 1 second. N, the number of atoms, is one of the few things that we'll come across which doesn't have any units, it's just a number. So we'll just go with that simple example we tried a second ago. Calculate the activity when 300 atoms decay in 6 seconds. Usual, analyse the question to get what information you've got. So the first thing you've got is that 300 atoms decay. So N is 300. Right, no units. Always feels a wee bit strange writing down numbers with no units. And we know that that takes, in this example, 6 seconds. So T is 6 seconds, and we're being asked the activity. The formula then, A equals N over T. N is 300, T is 6. A simple calculation, and the units, remember then, BQ becquerels. Now in reality it is very difficult to actually correctly fully measure activity, because it's actually difficult to measure every single atom which decays. Often we'll deal with things like count rates, which just mean what fraction of the atoms that decay that we're measuring. So if you think about it, if you've got a source and it's firing out radiation in all directions, your detector's only likely to pick up a small number of those. Okay, some of them might be absorbed before they reach your detector. So activity is a kind of idealised thing, right? That if you could measure every single atom which could decay. Often when we're doing questions we'll talk about count rate, right? Or counts per minute. And that's just a kind of the proportion of the overall activity that we're measuring.